These notes are going to go over section 5.5 of our textbook, which is the last day of our unit 1 in this course. It's going to talk about arc functions as well as solving right triangles. Arc functions are really just the inverse of a regular trig function. So the inverse of sine, cosine, tangent, cosecant, cotangent, or secant. And when you're thinking in terms of math, arc function always inverse functions undo each other. So for example, division and multiplication undo each other, subtraction and addition undo each other, logs and exponents undo each other. In that exact same way, arc functions undo trig functions. So when you have a typical problem, you would have, say, sine of x equals y. In this case, we're wanting to solve for the angle. The y in this made-up problem here is your ratio, and the x is the angle you want to know. So if I want to get that x by itself, what I do is I just rewrite it such that x is by itself, and now I have to have an inverse sign on the other side. Technically, you are doing the inverse sign to both sides, just like you do with maybe multiplication, addition, or subtraction. These kind of cancel, and then the inverse sign has to stay with the y. This is typically how you've seen it in the past with the little -1 in the exponent position. However, often that -1 can get confusing when our problems get more complicated, so we have another way to write it as well, and that's using just arc sign. So these mean exactly the same thing. Sine with the little -1, your inverse sign notation here is always what you'll see on your calculators. But often when our problems get super ugly, we will just write that as arc sign so that we know, so that we don't get confused about what this -1 is. Okay, we're going to try a few different problems of different types all throughout this. This first one, what I would always do is start in your parentheses in math. We always start inside there. And I will remind you that arc cosine of 4/7 is really just if I knew cosine of some angle equaled 4/7. Writing it like this can help it to look more familiar to what we've done in previous classes, where you're given cosine of some angle equals the ratio of 4/7. And now I can actually use that to solve. So what we did in previous classes is we drew that triangle. I'm going to put my x in one of the angles. That's my angle that I'm talking about up in the problem. And then I know this 4 is adjacent, and the 7 is the hypotenuse. And now I can go over and solve for this height using the Pythagorean theorem. So we know, I'll let this be a squared plus 16 equals 49. When you subtract it over, a squared equals 33. And so my a is just the square root of 33. Why that helps me is I really want to know sine of this angle x, because remember, all of this is really equal to your angle when you do your arc cosine. So I want to know the sine of this same angle x from my picture. But now I know all the sides of my triangle, so I can. Opposite is the square root of 33. Hypotenuse is the 7. Here there's no indication of quadrant, so you won't have to worry about that. And that's just my final answer. What I would suggest is to go ahead and try this one. Pause the video to give yourself a second to work it out, and then play it when you're ready to hear an explanation. So again, I start in the parentheses. This is where I have most of my information, and this really tells me that the sine of x equals 1/3. So I'm going to draw this triangle. The 1 is opposite, the 3 is the hypotenuse, and then say this is my x that I want to know. I know that 1 plus x squared equals 9. So x squared, got ahead of myself, is 8. And x is 2 root 2, because you do have to simplify that radical there. So don't leave it as the square root of 8. Make sure you pull out that 4, since that's in there. So that is this side. And then I can go ahead and focus on my cotangent, because it really wants to know the cotangent of that same triangle. Cotangent is the reciprocal of tangent. Tangent's opposite over adjacent, so cotangent would just be adjacent over opposite. So it's going to be 2 root 2 over 1, or just 2 root 2. Okay, the rest of what we're going to, or the next part of what we're going to look into is actually solving right triangles. First off, whenever I ask you to solve a right triangle, you need to find all angles and all sides. We did this a little bit last class, but we were only finding angles. We hadn't talked about inverse trig yet. So here it's going to look similar, but you're going to find everything. So I have steps here listed for you, just as a generic way to work through the process. You will need a calculator for this part. So do make sure once you've written down the steps, grab a calculator, and then we can go ahead and try some problems. So when we do these, I'm going to give you some information. When I give it to you here, I'm always going to make my C be the 90-degree angle. On your test, I will give you a picture. In the book, it gives you a picture to be able to label correctly. But we're going to label all of our information. Remember that the little a and little b are what are across from your angles. So since this is angle B, this is side B, so that's where I'll put the 20. So angle A is up top, side A is on the bottom. We need to find everything, and there's not one order that works for this. You can do it in multiple different ways. Often what people notice first about this is that you can find your hypotenuse right off the bat the same way that we have been doing. So you're going to use your Pythagorean theorem to do that. You should get from your Pythagorean theorem that c squared is 1076. On this part of your test, it does tell you you can round to the nearest tenth. Because the angles will be the nearest tenth, and often with trig you're not going to get a radical, so I'm not going to worry about having you simplify this radical here, and it will reiterate that to you on the test. But again, then when I square root this just in my calculator, I get 32.8. So I have found one of the pieces of information. Now I just have to find the rest. Say I decided I wanted to find A first. The order here does not matter. What I will always recommend is using the information given to you, not information you found. Partially because the information you found was rounded. So we rounded this square root of 1076 to be 32.8. If you use the exact value, it will still keep it exactly correct, but I wouldn't use a rounded value. And the other is just in case your C is wrong. Okay, so I will always use the given information. So when I'm trying to find A, I'm thinking about how it's related to the 26 and the 20 that were given to me. To the 26 is opposite, the 20 is adjacent, and so that's going to let me set up the tangent of A would equal 26 over 20. As we've talked about, I need to get this A by itself, so this is where I'm going to do the inverse tangent, and I'll write it this way for now because that's how your calculator shows it. The inverse tangent, oopsies, of 26 over 20. Your calculator needs to be in the correct mode for this, but typically you'll push second tangent, your 26 over 20. You should get 52.4 degrees. If you don't, more than likely your calculator's in the wrong mode, so just double check that on yours. Once you've found one angle, you can use another trig ratio just like we did for angle A to find angle B, but you can also just know what your total in a triangle has to add to equal. I'm okay with either way. I'm going to go ahead and use a trig ratio since that's what's newer, and that's what also won't use a rounded or possibly incorrect answer. So if I want to find B, I can use tangent again, but now I have to remember that now the 20 is opposite and the 26 is adjacent. So tangent of B, I'm just going to flip that. It's going to be 20 over 26. And again, my B will be the inverse tangent of 20 over 26. Again, you have to have a calculator for that. Make sure you are practicing it and not just believing me. 37.4. The nice thing, if you do it this way, you can kind of check your work. These two answers, the 52.4 and the 37.4, should equal to 90 degrees since the whole triangle is 180 and I already have a 90. So if I do 52.4 plus 37.4, 6. Sorry, that was supposed to be a 6, not a 4. Right here. Just wrote it wrong. That does in fact equal 90, so that means I'm probably on the right track. That's a good trick to use on your test if you want to make sure that you're doing these correctly. Go ahead and take a second and write this one down, and I would try it. Then play the video when you're ready to hear an explanation for it all the way through. So with this one, I cannot do Pythagorean theorem right off the bat because I only know one side. So I'm going to focus more on finding just one side at a time. One thing you can do first, actually, if you notice this one, I have 2 angles. So we can immediately find this angle by just adding up to 180. And so that missing angle A is just 50. And you really don't have to do much any upper level math to get that. It's just knowing that your triangle adds to 180. Then you really want to find your sides. And you can use the 40 or the 50 since you know both are correct and neither are rounded. I'll just use the 40 since they gave that to me. From the 40, the A is my adjacent and the 20 is my hypotenuse. So the trig ratio that compares those is going to be cosine. So cosine of 40 is equal to A over 20. And this goes back to last class, and you can just solve it by doing 20 times the cosine of 40. And I get that my little a is 15.3. I'm going to go ahead and do really the exact same thing to find side B. But I'm just going to need to know that this B is now opposite from my 40. I, again, always use my unrounded numbers, so I'm going to do my opposite and my hypotenuse, even though I do also know my adjacent. You wouldn't necessarily get it wrong, but again, I just like to use unrounded numbers that I know are correct. So sine of 40 equals B over 20, and again, you can just do 20 times the sine of 40, and side B is 12.9. When you're looking at these, there is a way to kind of check it and make sure you're right. Remember that with right triangles, your angles and your sides should go in increasing order. So since this 40 is the smallest angle, the side opposite it, the B, should also be the smallest side. So it's good that 12.9 is smaller than the other 2 numbers. Same idea, the 50 is my middle-sized angle, and the 15.3, its opposite, is the middle-sized side. So if you use that to help you check as you go through. I'll work out one more example here since we're doing it in a video. So again, feel free to try it and then play the video when you're ready to hear the explanation. Okay. With this one, again, I would start by finding my little a down here because that's my only missing side, and I can do the Pythagorean theorem to do that. When you do that, it's going to be a 4. Then I'm going to go ahead and find my sides, and again, you can do it in any order you want. Or sorry, my angles, not my sides. I already know my sides. If I want to find a first, I'm going to use this 3, the adjacent, and the 5, the hypotenuse. So that means I'm going to use cosine. So I know the cosine of A is equal to 3 over 5. So that means I need to get the cosine away from it. And I'm going to type into my calculator the inverse cosine of 3 over 5, which I get to be 53.1 degrees. Same thing to find B. But again, now this 3 is opposite. So that means I'm using sine of B equals 3 over 5. So to get the angle, as always, you have to do your inverse. And you get 36.9. Again, these 2 numbers should add to 90, so that's an easy check for you to do to make sure that you did it correctly. Okay. The next part we're going to get to is dealing with our no calculator part of our test and our exact values that we've talked about in the past. So take a minute and write these down. What I will tell you, these first two steps are on both this slide and the next one. So if you want to write it down just once, that's fine. The red is where it will dictate the specifics based on the type of angle that you have. So again, write down this just once, even though it'll be on this slide and the next. Pause it on each slide to make sure you have time to write it down. It is important that there is an S here on the solutions. You'll notice it's red because there could be multiple solutions to every single problem, which is probably what we're going to talk about kind of in detail as we go. But that S is pretty important. Here are the steps for if you are solving a trig equation and you have a quadrantal. So again, these first two are exactly what you saw on the last page. The bottom two are what's more specific to our quadrantal angle. Okay, I'm just going to work through multiple examples of these. Again, this will be no calculator on your test, so I would make sure to not use one here. Okay. When we go through these, the first thing it says is to take the arc function of it to make sure that your angle is isolated. This is technically just making sure that you know that it's not, that's how you're finding the angle. I will never mark off if you don't do that, and eventually really won't even write it anymore, but know that to find an angle, you're always doing your arc sine of both sides, or arc cosine, arc tangent. Then you want to figure out, hey, this ratio, does that look like a ratio from a special right triangle or from a quadrantal angle? And this is where knowing your day 3 of the chapter is going to be exceptionally important. When I look at this, what can help, since I know it's sine, this root 3 is going to be my opposite, and the 2 is going to be my hypotenuse. What that can do for me is remind me that I'm really looking for a triangle with a leg of root 3 and a hypotenuse of 2, and we do have that in our 30, 60, 90 triangle. It is important you draw these correctly, so be careful there. It's crucial that you place the angles opposite the correct side. So we've identified that this is a special right triangle, and we've identified which one. We now need to figure out which ratio this is. So since this is opposite is the root 3, that tells me that I need the angle opposite the root 3, which is going to be my 60. So my reference angle is 60 degrees. Then we need to think about where this angle is, and this is where you're going to get multiple solutions from. The where goes back to your cast that tells you where everything is positive or negative. We need to think about two things. We need to think about what trig function we were given and whether our ratio was positive or negative. So here I have sine, and it is negative. And so I need to figure out where on this chart sine is negative. Well, according to this, everything is positive in quadrant 1, so it's not going to be there. Sine is positive in quadrant 2, and so for the sine to be negative, it is either quadrant 3 or quadrant 4. And so you are actually going to give me both. Okay. Then we're going to continue to work backwards. This is where we can think about either our picture or the formulas that we memorized in the start of the chapter. But we know right now that our reference is 60 and we know the location. And now we're going to find the actual angles themselves. So in quadrant 3, we know we really just need to add on this top part right here, which is 180. Okay, 180 plus that 60 gives me a 240 degree angle. So that's one of my two answers. So again, you can either do it from the picture or you can memorize that in quadrant 3, you will always add 180 to your reference. Either is totally fine. In quadrant 4, I know I want, oopsies, all of this over here. Okay, and what we talked about before was, remember that the whole thing adds to 360, so we really need to know the rest of it. We want to know just this portion, so we're really doing the 360 all the way around minus that 60 that's taken up by the reference angle, which gives me an angle of 300 degrees. Again, you can also use the formulas we talked about on day 3 and really just subtract 60 from 360. But if the pictures help you, do that as well. Okay, we're gonna go ahead and try this one as well. Again, the first thing I do is I just remember that I am isolating this angle by doing the arc cosine of both sides. And then I think about, okay, do these look like numbers from a special right or a quadrantal? And in this case, these are numbers from a special right. Your quadrantals will only be 1, 0, or undefined. This isn't that, so this has to be a special right triangle. But what's kind of tricky is that means I need to have a leg of root 2 and a hypotenuse of 2, which we do not have a triangle for that. But what I want you to think about is when you finished this problem, if you were finding this angle, you would have rationalized it. So we need to be thinking about what this number would be before you rationalized the problem. Okay, we would have multiplied top and bottom by root 2 to get to this answer, which means before my problem would have been 1 over root 2, that we would have rationalized again to get that. This is helpful because I do have a hypotenuse of root 2 with an adjacent of 1. It's going to be the 45, 45, 90. Okay, again, the better you know your day 3 of the chapter, the easier these are going to be. So this tells me that my reference angle, in this triangle it's easier because the angle can only be a 45. You don't have 2 choices like we did in the other one. Reference angle is 45. We need to now know where. So thinking about cast, I have cosine and it is positive. So I need to know where cosine is positive. Well, cosine is positive where all of them are positive, and also down here where cosine is positive. So it's in quadrant 1 and quadrant 4. Drawing the pictures, if that helps you, that means I'm looking at a quadrant 1 angle and a quadrant 2 angle. In quadrant 1, my reference is always equal to my coterminal, so this is going to be a 45-degree angle. In quadrant 4, it's just like before, where you will always do 360 minus your reference, or minus that 45, and you're going to get a 315-degree angle. I would go ahead and try this one, but I would be careful because it is often accidentally misidentified by people as to what type of angle it is. When you're ready to hear the explanation, go ahead and play the video and I'll talk you through it. So again, we're going to start by isolating that angle. So we would do the arctangent of both sides. And I'm going to write this one as a fraction because all my ratios at least start as a fraction and then I usually simplify them. So I know that tangent is the opposite over adjacent. And I need to think about what has an opposite and an adjacent of 1. Now, what I said a minute ago is your quadrantals are always going to be a version of 1 or 0 or undefined. However, that does not mean that every time you have 1 or 0, just 1, that it is going to be a quadrantal, because tangent does have a triangle where the opposite is 1 and the adjacent is 1, and that triangle is your 45. Okay, if we were doing a quadrantal with this, that would mean we would need an x and a y that both have a 1, and we don't have a quadrantal ordered pair where that is the case. So this is not a quadrantal, it is going to be a special right. But again, that now tells me that it is a reference of 45, and I need to figure out where. It is tangent, and it is negative. So they are all positive when 1, tangent is positive in 2, so that means I am down to either tangent is positive in 3. I am down to either quadrant 2 or quadrant 4. Again, I'll draw the pictures. If you don't need the pictures and you use the formulas, that is fine. In quadrant 2, we know that the coterminal and the reference have to add to 180. So we're really just removing the 45 from the 180. So you can always do 180 minus 45. And that will give you 135. Again, in quadrant 4, you always do 360 minus your reference, which gives us, again, the 315. give this one a try. And then again, when you're ready to hear the explanation, go ahead and play the video. To isolate it, I'm going to do the arcsecant of, and I'll write it as 2/1. If you would rather change it to its reciprocal, you can absolutely flip this to be cosine of x equals 1/2. That's really just your preference. Then when I'm looking at this, secant, again, is the reciprocal of cosine. So it's h/a. So I need a hypotenuse of 2, which is going to be my 30, 60, 90. Okay, that's where it is super important to know what triangle is what and have your radicals in the appropriate location and all your sides. So I need a hypotenuse of 2, which is either angle. So this adjacent information is really what's more important. I need it to be adjacent to the side that is 1, which tells me it is going to be a 60-degree reference. Then I think about the where. Secant, I'm going to pretend is just cosine, because again, we go based on the reciprocal. And it is positive, so it is going to be quadrant 1 where everything is positive, and quadrant 4 where cosine is positive. In quadrant 1, that means I'm just going to have a 60-degree angle because, again, that's always the same. In quadrant 4, since we've done this a few times, remember it's just 360 minus your reference, or 300. Feel free to draw those pictures if you need to think it through. Okay, these next couple are going to be quadrantals, and so I wanted to just take a chance to go through these as well and what changes. Again, your process as a whole is the same, but you have to think about those circular functions that we talked about on day 3. So again, I'll start by doing the arc sign. This is a 0/1. It's important to remember that this is really your ratio, not your angle. Some people get it flip-flopped here because 0 can also be a degree measure, but this is your ratio. So I put it over 1 to remind myself of that. Sine is opposite over hypotenuse, but because this is a 0, I don't have a triangle with a leg of 0, so I need to write this as x, y, and r. Opposite is always your y value, and your hypotenuse is always your r value. So what I know right now is that my y is 0, and it is 1 unit away from the origin. So we need to think about, we're going to draw this ordered pair, or sorry, the xy axis. I'm going to label all 4 points for now to really remind you of what we talked about. These are my 4 options for quadrantal points, or for the ordered pairs you're going to use. All I know right now is that y is 0 and it's 1 unit away. All of them are 1 unit away, so this isn't as helpful, but I need to figure out, where do I have a y value of 0? Is it once? Is it twice? Is it 4 times? What am I looking at? When I look at these, it's not the y-axis values because those have a y of 1. And then I notice that my x's, both of them have a 0, and so my answer needs to include both of them. Okay, so sometimes you will have 2 values, and it's always when you have a 0 here, because you don't know whether it was positive 1 or negative 1, so I need to include both of them. So again, we looked at, of my 4 options, which had a y value of 0, it was both of these. And so then we're going to translate that into angle measures. At 1, 0, it is a 0-degree angle, and at -1, 0, it is a 180-degree angle. I would always label your angles with this degree again, so you don't get confused between a ratio, a trig ratio of 0, and an angle measure of 0. Those are 2 different things, so be careful there. Feel free to go ahead and try this one. If you want to be talked through it away, that's fine. But this will be the last example we do on here. So again, we start by doing the arc cosecant of both sides. I'm going to write this as 1/1. Cosecant is the reciprocal of sine, so that means this is hypotenuse over opposite. I do not have a hypotenuse of 1 anywhere, so that does tell me that this has to be a quadrantal. So I know this is my radius, and my O, again, is my y value. And so we're going to think through the same process. When we fill this in, we talked before our radius is always 1. And so this negative is really going to apply to our bottom number down here. Remember, when you have that negative, it could have been your top or your bottom number. -1 divided by 1 is the exact same as 1 divided by -1. So we have to pick where it goes, and it will never go with your radius. It will always go with your x or y value, whatever it is. So that means that my y is a -1. Then if I look at my picture again, and I'll label all 4, since it's on my different slide, we need to figure out, where do I have a y value of -1? Is it one spot, multiple? What is it? We can play the same process of elimination as before. These two on your x-axis have a y of 0, so that's not it. And this positive y-axis has a 1, not a -1. So my only answer is down here at 0, -1. Translating that into a degree measure, it is going to be a 270, sorry about that, degree angle. So your quadrantals will sometimes just give you one answer and not two. And you will just have to go through this process to make sure you know which case it is.